Hi everyone, it's Maths with AUB. I have chosen the topic for you, my tiny effort, how to find the domain of the function. How to find the domain of the function. There are a variety of functions, algebraic functions, trigonometric functions, hyperbolic functions, log functions. Log, hyperbolic, exponential functions are collectively called as transcendental functions. Domain is a complicated topic, difficult to hunt, difficult to comprehend, but keep three sentences of mine in your mind and you are going to get through. Denominator doesn't vanish. Exclude all the values where the denominator is completely zero. Number one. Number two, in square root, no negative value is affordable. No negative value is affordable because in calculus we mostly deal with real valued function. With real valued function. In square root, we cannot afford negative sign because it leads to complex numbers or iota. Number third, log is defined by whether it is ln or log. They are defined for positive quantities. Log are defined for positive quantities. In root, we cannot afford minus. In denominator, overall, we cannot afford zero because zero division with zero is not allowed in mathematics. Because division with zero is not allowed in mathematics. Let's see our question number one. Let's see our question number one, what it states that our function f of x is equal to root x square minus x overall x square plus x minus 2. First of all, we have to find out the values where the denominator vanishes. Where the denominator vanishes. We have to sort out the values of x where the denominator vanishes. Denominator becomes 0. Let's find the roots of the denominator. X square positive x minus 2 is equal to 0. A tiny trinomial 1 to the 2, 2 minus 1, 1, x square. 1 can be written as 2x minus 1x minus 2. Trinomial x common, x plus 2 minus 1 common. Whenever minus common, change the upcoming symbol, it will become x plus 2. First bracket is x plus 2. The other one is x minus 1. Solve for x, either or. X plus 2 is equal to 0. It leads us to x is equal to minus 2. X minus 1 is equal to 0. X is equal to 1. So simply, in the domain, we cannot afford minus 2 and 1. Minus 2 and 1. We have neutralized the denominator by excluding minus 2 and 1 from the domain. Minus 2 and 1 from the domain. Don't forget, there is double twist in the tail in case of square root. In case of square root, we need quantities that gives us greater than or equal to 0. Equal to 0 is affordable in numerator. Equal to 0 is affordable in numerator, not in denominator. Taking x common, we have x minus 1 is greater than or equal to 0. Either x is greater than or equal to 0. X minus 1 is greater than or equal to 0. It leads us to x is greater than or equal to 1. How to manage all these? Look at this. This states that x is greater than 0. It states that x is greater than 1. X is greater than 0 or equal to 0. And that is, suppose it is our starting origin, it is 1. It states that x is greater than 1. Greater than 1 means either we have to select this or we have to select this. That is the portion to be calculated rigorously. That is the portion 0, 1, 0, 1, 0, 1. Mark my words. Let me give you another idea. Another good tip how to solve inequalities or such type of question in case of root. Where is blue pen? Let me find blue one. These are the values 0.1 something, 0.2 something, 0.3 something, 0.4 something, 0.5 something, 0.6 something, 0.7 something, 0.8 something, 0.9 something, and so on. Look, I have written like a child 0.1, 0.2, 0.3 or any figure after 1 are possible. This is the interval of the values of any variable where our mathematics is almost reciprocal. Where mathematics is almost reciprocal. And normally, this is our ascending order. This is our ascending order. For these types of values, this is our ascending order. For such type of values, x square, x root. Means x square is less than x and x is less than root x. For such type of values, our mathematics is almost reciprocal. Normally, that is the case. Root x, x square. It is our ascending order for all the values except these. For for all the values except these, for all the values except these, for these values, that is our ascending order, that is our ascending order. Normally it is descending, but in case of these values 0.1 something, 0.2, 0.3 up to 0.9, that is our ascending order, that is our ascending order. So in that case we have to exclude this 0 and 1. Let's check out this one. If I put something 0.1 here, 0.1 square minus 0.1. So normally 0.1 is less than 0.1. That is less than 0.1 square is less than 0.1. So it results in negative quantity. Take any other value, either 0.1, 0.2, 0.3 up to 0.9. These values we cannot afford because they gives us the numerator, sorry, the root, square root negative. Square root is negative for all these values, for all these values. That's why I have written like a child for you. That is our ascending order in case of such, otherwise it is descending order, and we cannot afford all these values from 0 to 0 point something to 9, 0 point something to 1, 0 point something to almost 1, excluding 0 and 1, excluding 0, 0 and 1 we can afford. If I put 0, the complete numerator is under root square root is 0, 0 is affordable. In case of 1, 1 square minus 1, it is also 0. 0 and 1 are affordable, but between 0 and 1, between 0 and 1, we cannot afford between 0 and 1, from 0.1 to up to 0.999, whatever the case is, we have to exclude that portion, exclude that portion. We have to exclude for the domain minus 2 and 1 because their denominator vanishes. These are the roots of the denominator minus 2 and 1. Here, that is the tiny interval from 0.1 to 0.9 and something. We have to exclude that portion, exclude that portion. What about the rest we can take? How to write the domain of this function? All values are affordable from minus infinity to minus 2. Here 2 is excluded. It is our open interval. It is our open interval. It is our open interval. 2 is already excluded. Good. There is also 2, minus 2 is excluded in that case. Here 0 is included. We can afford this, and 1 is also excluded. We cannot afford 1 in case of denominator. In case of denominator. So look at this, and there these two options are almost identical. These two options are almost identical. Where lies the difference? This is only delicate and fine difference of 0. In that case 0 has been excluded. In that case 0 is included, 0 is included, and our 0 is included in our domain, because if we put 0, 0 minus 0, it's 0, 0 plus 0 minus 2, yes, it is affordable. So from these two delicate options, look at almost each and everything at same. Where the MCQs goes, by hunting the appropriate position of 0. 0 we can afford. 0 is in our denominator. 0 is in our domain. 0 is in our domain. 0 is in our domain, and 1 is not in our domain from this point of view. So discarding this option, that is the right option in that case. That is the right option in that case. Let me summarize again. In case of under root, we cannot afford negative values. We cannot afford negative values, and the denominator doesn't vanish. Denominator doesn't vanish. So take care of these two things. In case of algebraic expression, there is neither trigonometric functions nor log. Okay, go sell through. Question number 2, almost a replica of this type, but it will give you a good concept as well. Let me charge the marker. Look at this. Denominator, try to sort out the values where denominator vanishes. Put denominator is equal to 0, 1 to the 2, same difference of, sorry, middle term breakup, x square minus 2x plus 1x minus 2 is equal to 0. Taking x common, x minus 2 plus 1 common, x minus 2, we have two brackets, x minus 2 and x plus 1, they are equal to 0. It gives us x is equal to, it gives us x is equal to minus 1. So we have to exclude 2 and minus 1. We cannot afford them in domain because both of these values gives us denominator 0. What about the uppercase? X square minus 9 must be greater than or equal to 0. Greater than or equal to 0, equal to 0, or all 0 in case of root, and in numerator we can afford. Root in numerator or all 0 we can afford. So x square is equal to 9, or x is, in that case we have to write x square, x is greater than or equal to, that is the way to write this one. Minus 3 is less than x, x is less than 3. the interval, overall interval in that case. X square is greater than 9 or x is greater than or equal to plus minus 3. I have converted plus minus 3 into the interval minus 3 and this one. Again, check the portion. Check the portion. That is the portion or blind area where we have to check some inquiry of this one minus 3 to 3. If I put here 2 between these values minus 3, minus 2, minus 1, 0, 1, 2 and 3. Check these values. These are affordable. If I put minus 3, 3 square, 9 minus 9, good. This one 3, 3 square, good, good. What about these two values? Minus 2 square means 4 minus 9, it will give me minus 5. So we have to exclude, that is the middle one, because these are the values from excluding minus 3, almost excluding 3. All this interval gives us negative values in the denominator. We have to exclude that portion between minus 3 and 3. We can afford minus 3 and 3. We have to exclude this portion between minus 3 and 3. So what about this? Minus infinity to minus 3, each and everything is affordable. What are these two values? These two values also lie here. Minus 1 is there, 2 is also there. So they are automatically excluded by the blessings of this interval. So our right option in that case is minus infinity to minus 3. We can afford. From minus 3 onwards to 3, we have to exclude that portion. Minus 3 to 3. 3 we can take, 3 is included, positive 3 is included. That middle portion we cannot afford. That is the middle portion we cannot afford because it gives us our root in the numerator negative. Root from these all these values between minus 3 and 3 results in negative, and we have to exclude minus 1 and 2 because of denominator. Minus 1 and 2 because of the denominator. They are automatically excluded by the blessing of minus 3 to 3. So our right option in that case is we can take all values from negative infinity up to minus 3, excluding from minus 3 onwards to positive 3. Then from positive 3 to positive infinity, we can afford each and everything. We have to take care of three things. Root can never be negative. Denominator never be a 0. And there is no concept of log in that video. For upcoming video, I have selected some questions for you and I can solve. What about this one? Last but not least, another good question. For what value of x? For what value of x? H of x is equal to 1 over x minus 3 overall square plus 2 times x minus 3 minus 8 is undefined. So we have to, same undefined means we have to find the values of x where this function ceases to be ceases to be defined. Means we have to sort out all the values where the denominator becomes 0. Denominator becomes 0. We have to sort out the zeros, the factors, the roots of this denominator. Equal this equal to 0, x minus 3 whole square plus 2 times x minus 3 minus 8 is equal to 0. If we suppose x minus 3 is equal to y, suppose, in order to facilitate our work, suppose x minus 3 is equal to y, it will become y square plus 2y minus 8 is equal to 0. To for that, again middle term breakup, positive 4y, negative 2y minus 8 is equal to 0, y common, y plus 4 minus 2 common, y plus 4 is equal to 0. So y plus 4 is the one bracket, other root, y minus, other bracket is y minus 2. Solving, we have y minus 4 and y is equal to. These are not our answers. We need values of x. What we have supposed x, we put values here. X minus 3 is equal to y. What is y? Y is our minus 4. X minus 3 is equal to minus 4. Solve for x, it will become minus 1. What about this? This is y also equal to x minus 3 is equal to 2. So x is equal to 2 plus 3, 5. X is equal to 5. Means we have to exclude minus 1 as well as 5 because they do not satisfy our denominator, because both of these values gives us denominator 0. Both these values are the roots of the denominator. Both minus 1 and 5 are the roots of the denominator. They will give us the denominator 0. That's why we have to exclude from the domain, or one can write domain. We can afford all real numbers excluding minus 1 and 5. Look, I have marked curly bracket. Curly bracket means only minus 1 and 5. The rest we can take. Again, let me emphasize on you that you have to hunt two to three things. Denominator never vanishes, square root never be negative, and log is not defined for negative values. One thing more, that is the interval to be kept in mind between 0 and 1, between 0 and 1, excluding 0 and 1, between 0 and 1, not from 0 to 1, between 0 and 0 0.1, 0 0.2, 0 0.3, up to 0.9. These are the values where almost mathematics is reciprocal. That is the normal case of our ascending order. In case of these values, that is our ascending order. That is our ascending order. X square, x, x. Normally it is descending order. In that interval, for that interval only, that is our ascending order. That is our ascending order that I have to tell you. That's all by itself. Next.